Hello, students. This is Mrs. Gregorio. Today we are covering Lesson 3.2, which is an extension of Lesson 3.2, and we're learning how to factor expressions. So follow along with me in your textbook on page 92. Now, today you are watching the Edpuzzle video in class. So I would like you to complete the warm-up, numbers 1 through 6, by finding the greatest common factor. And I'm going to review what the greatest common factor is with you, just in case you need a little refresher. Let's say we have the numbers 5 and 35. The factors of 5 are 1 and 5. The factors of 35 are 5 and 7. You look for the factor that they have in common. In this case, it would be 5 here and 5 here. So the GCF of 5 and 35 is 5. You can also list it instead of showing a tree diagram with the prime factorization. If you did a list, it would look something like this. The factors of 5 are 1 and 5. The factors of 35 are 1, 5, 7, and 35. The greatest factor that they have in common is 5. Now, I want you to notice that 1 is not a common factor. Every number is divisible by 1, so that one doesn't count. So I need a factor that's greater than 1. Go ahead and try these problems and pause the video to work it out. And now let's continue example 1 on page 92, factoring out the greatest common factor. So if you see the expression 24x minus 18, this can be factored, meaning we can take out a common factor that both of the coefficients have in common. So let's look at the coefficient 24 and 24x. And then let's look at 18, the constant. A number that goes into 24 and 18, I'm just going to list the factors off to this side here. 24 is divisible by 1, it's divisible by 2, 3, 4, 6, 8, 12, and 24. Many factors in the number 24. 18 can be divided by 1. It can be divided by 2, 3, 6, 9, and 18. The factor that is the greatest number that they both have in common is 6. So I'm going to divide 24 by 6, and then I'll divide 18 by 6. So I take out the greatest common factor, 6, and then I put parentheses to show distributive property. 6 goes into 24 4 times and bring down the x. Keep the same sign, it's subtraction. 6 goes into 18 3 times. So our expression would be 6 times the quantity of 4x minus 3. Now, if you want to go back and check your work, use distributive property to check. 6 times 4x is 24x, and 6 times negative 3 is negative 18, and that is the original expression we started with. So when we check our work, it is correct. Now let's try example 2. Oops, I'm sorry, that should be example 2. Okay, factoring out a fraction. This time we're going to divide out a fraction. Now, if we factor out 1/2 out of 1/2 x plus 3 over 2, or 3/2, there might be a simpler way other than just dividing by the fraction. If you look at 3 over 2, you might see it as 3 over 1 times 1/2. which is still 3 over 2. And then we still have the 1/2 x. So what I'm doing is I separated out the 1/2 from 3 over 2. And the 1/2 is very visible from 1/2 x. So now let's take out the 1/2. Okay, I factor it out, put the parentheses there. 1/2 goes into 1/2 x one time, with the x left over. Remember, I don't need to show invisible 1, so I'm just going to show this as x. Plus, keep the same sign. Now, 1/2 goes into 1/2 3 times. I'm sorry, 1 time goes into it exactly. And then if they go evenly, it's like they cross out or cross cancel, and all I'm left with is 3. So if I take out a 1/2, divide it out, then I'm left with 1/2 times the quantity of x plus 3. Let's check our work to see if this is correct. 1/2 times x is 1/2 x. And 1/2 times 3, or 3 over 1, is 3 over 2. And that's exactly what we started with up here. Another way you can look at this problem is simply by dividing. If you have 1/2 x plus 3 over 2, divide out the 1/2, you can see that 2 is a common denominator and 1 is divisible. So you can start with 1/2 and test it. 1/2 goes into 1/2 one time. Again, there's just the x. 1/2 can go into 3/2. So think about it like this. 3 over 2 divided by 1/2. Well, when we are dividing fractions, you're multiplying by the reciprocal, which would be 2 over 1. And from here, you can cancel out the 2's and you're left with 3. So you can still do it using the division method here. You get the same answer either way. Our last example is example 3 on page 93. This time we're factoring out a -2. -2 out of -4p plus 10. It tells you what number to factor out. So this case, we take out the -2. And we have to ask ourselves, how many times can -2 go into -4p? So think about it like this. -4p divided by -2. When they have the same sign, our answer will be positive. 4 divided by 2 is 2. Keep the variable p, so this becomes 2p. Plus, now -2 can go into 10, positive 10, -5 times. Think about it like this. 10 divided by -2 equals -5. So I'm going to put the -5 in the parentheses. Now let's go back and check. -2 times 2p is -4p. That's where we started with. And -2 times -5 is positive 10. So when we check our work, we are correct. Okay, at this time, I would like you to try on your own numbers 1 through 4. This is a matching problem. And then you will have some classwork activities to work out with your partner. I hope you have a great day, and I will see you tomorrow in class. Bye-bye.